Hi everybody, in this video we're going to be going through the practice exam for Unit 4. So one thing to remember on this is anytime you're asked for a probability on this exam, you want to enter it as a decimal. So you can think about it as a percentage, but all of the questions on the test should be answered in decimal format. So on question 1, it says, if you spin this spinner, what is the probability that it will land on a number less than 5? So the way that we would calculate the probability of it being less than 5 is we would say, well, there's 10 possible outcomes on this spinner because you have the numbers 1 through 9 as well as 0. And out of all of those numbers, the number 4, 3, 2, 1, and 0 are all less than 5. And so we have 5 outcomes that are less than 5. And in decimal format, if you do 5 divided by 10, that's going to give you 0.5. So that would be the correct decimal probability for question 1. On question 2, it says, draw a choice tree to find the sample space of flipping a coin 3 times. So the way that you would do this is you would say, okay, well, my first coin flip could either be a head or a tail. My second coin flip could either be a head or a tail, regardless of which one I got as my first choice. And then my third coin flip could also be a head or a tail. So it's going to look something kind of like this. And remember, this choice tree corresponds to the sample space of each of, like, the results of each of these branches of the tree. So one possible outcome is you can get 3 heads. Another possible outcome is you can get 2 heads and then a tail. Another possible outcome is get a head, a tail, and then a head. Another outcome is get a head and 2 tails. And then like this branch right here represents getting a tail and 2 heads. This branch represents getting a tail, a head, and then a tail. This branch represents getting 2 tails and a head. And this branch represents getting 3 tails. So basically, there's 8 possible outcomes for this choice tree. So that would be how you do question 2, and you need the results from question 2 in order to do question 3. Because on question 3, it says if you flip a coin 3 times, what is the probability that you get exactly 2 tails? So we haven't found any formulas for situations where we want to have exactly 2 tails or exactly 2 outcomes. And so in this case, we just need to say, well, there's 8 possible outcomes from question 2. And out of those 8 outcomes, this one has we want 2 tails, not 2 heads. Let me fix that. So we could have this outcome, or this one, or this one. So those 3 outcomes are the outcomes where you have exactly 2 tails. And so you'd have 3 out of 8, which written as a decimal, if you do 3 divided by 8, you get 0.375. Or you can also think about that as 37%, but that decimal is what you would put on the answer for the test. And then on question 4, it says, if you flip a coin 6 times, what is the probability that you will get at least 1 tail? So we do have a formula for at least 1. And the way that we would think about this one is the probability of getting at least 1 tail is going to be equal to 100% minus the probability of flipping a coin 6 times and getting no tails at all. Or you can also think about it as basically getting like 6 heads in a row. And so the way that you would calculate that is you would say, well, the probability of getting a head the first time would be 1 out of 2. The probability of getting a head the second time would be 1 out of 2. And basically you'll continue this for 6 coin flips. And if you multiply all of those together, the probability of getting all heads ends up being like 0.0156, so about 1% likely that you get all heads, which means that the probability of getting at least 1 tail is 100% minus that, which ends up equaling 0.984375, but I'll just round that up to 0.44. So it's about 98% likely that you'll get at least one tail. And then on question 5, on this one, it says, at a restaurant, the menu includes 5 salads, 6 entrees, and 3 desserts. And if you're going to order a salad, an entree, and a dessert for your meal, how many possible meals could you order? So in this situation, we're not asked to find a probability. We're just asked to find how many possible meals we could order. So we have 3 events, and the number of ways that the first event could happen, excuse me, would be 5, because I have 5 salads to choose from. And then I have 6 entrees to choose from and 3 desserts. So the number of ways that I could choose my entire meal would be 90. I would have 90 possible meals that I could order. So one thing to notice is that if it asks for a probability, your answer should always be between 0 and 1. But if it asks you how many ways you could order it, or how many ways you can do something, that number should always be a whole number. Like in this case, it was 90. So if we move on to question 6, on this one, we're trying to find the sample space for rolling 2 regular-sided dice by drawing a table or a choice tree. And the question is how many possible outcomes are there? So I'm going to do this by drawing a table. So basically my individual possible outcomes are that I can get either a 1, a 2, a 3, a 4, a 5, or a 6. And on the other dice, I can get a 1, a 2, a 3, a 4, a 5, or a 6. So this is basically the table that we did on the dice project earlier at the beginning of this unit in class. So let me just write this out really quick. Okay, and then I'm going to write out the individual outcomes, because on question 7, I'm going to try to find the probability of rolling a 7, meaning that the dice add up to 7. So I'm going to add up what all of these outcomes end up working out to. So if I roll a 1 and a 1, that gives me a total of 2. If I roll a 2 and a 1, that gives me a total of 3. 3 and 1 gives me 4. And there's kind of a pattern to this, because each time you increase one of the dice by 1, all of the other the result increases by 1. So if I roll a 1 and a 2, that gives me a 3. 2 and 2 gives me 4. And then 5, 6, 7, 8 should be that last one. And then a 1 and a 3 gives me a total of 4. 2 and 3 gives me 5, 6, 7, 8. I don't know why I keep wanting to write 2 7s in a row. But it would look like that. And then you'd have 5, 6, 7, 8, 9, 10. And 6, 7, 8, 9, 10, 11. And 7, 8, 9, 10, 11, 12. So those are all of the possible outcomes that you can get. And the number of possible outcomes is what we want to find for question 6. And so if you look at how many blue numbers there are in that table, there's 36 of them. Or you can also find that number by doing 2 events, because you're rolling 2 dice. Each outcome or each dice roll has 6 possible outcomes. So you have a total of 36 possible outcomes for rolling 2 regular 6-sided dice. And again, you could find that number without writing out the table, but you will need the table for question 7. Because on question 7, it says if you roll 2 regular 6-sided dice, what is the probability of rolling a 7? So the probability of rolling a 7 is going to be, out of the 36 options that we found above, you have 1, 2, 3, 4, 5, 6 7s. And so that probability is going to be 6 out of 36. And in decimal form, that ends up equaling 0.166666, repeating. So about 16%, 16 to 17% likely that you would roll a 7. And that's how you would do question 7. And then on question 8, we're given this table that summarizes the math awards and science awards that were given to 100 students at the end of the year. So on question 8, we're asked to find, if you choose a student at random from 100 students who receive an award, what is the probability of choosing a boy or a student who won a science award? So remember, the probability formula for OR says that the probability of event A or B happening is equal to the probability of A happening plus the probability of B happening minus the probability of A and B happening. And then the AND formula says the probability of A and B happening together is the probability of A times the probability of B happening, assuming that A happens. So we're going to use the OR formula, which includes the AND formula. So we're going to end up using both of them to answer this question. So if I want to find the probability of selecting, I'm going to do this in a different color actually. So we're going to do the probability of choosing a boy or a student who won the science award. I'm going to start off with this first part of my formula, which in this case, event A is choosing a boy. So I'd say, okay, the probability of just choosing a boy would be 43 out of 100. Then I'm going to add that to the probability of the second event, which is just choosing someone who won a science award. So that'd be 48 out of 100. And then I'm going to subtract the probability of getting a boy and someone who won a science award. So you can do that just by looking at the table and saying there's 19 boys who won science awards out of the 100. Or you can use the AND formula to calculate this out. So to do this, I would take the probability of the first event, so in this case, the probability of choosing a boy, 43 out of 100, and then I would multiply that by the probability of choosing someone who won a science award, assuming that you choose a boy. So if I only have 43 boys to choose from, and 19 of them won science awards, that would be the calculation for the probability of choosing a boy, like someone who is a boy and won a science award. And you can see that when you calculate this out, 43 divided by 43 cancels out to 1, and you get that 19 out of 100 that I mentioned earlier that you can find just by like looking at the table. So either method works, but when you add and subtract these together, 43 hundredths plus 48 hundredths minus 19 hundredths ends up giving you 72 out of 100, which is 0.72 in decimal form. So it's 72% likely that you choose a student who is a boy or won a science award. On question 9, it says, if you choose a student at random from 100 students who receive an award, what is the probability of choosing a girl given that you choose a student who won a math award? So we assume that you're choosing a student who won a math award. So we have 52 students to choose from. And the probability of choosing a girl from that group of students is 28, because you have 28 students who were girls who won math awards. And when you put that in decimal form, 28 divided by 52 ends up equaling about 53%, 53.846, but we'll round that up to 8.5. And so that would be the answer for question 9. On question 10, it says, in a large population, 28% of the people ride the train to work. If you randomly select 3 people, what is the probability that none of the people you select ride the train to work? Okay, so in this situation, we're selecting 3 people. So we have 3 events, and it's 28% likely that someone will ride the train to work, which means that it's 72% likely that they don't ride the train to work, because 100% minus 28% is 72%. So you could write this as a fraction. However, we don't know what the entire population size is, so it's easier if you think about it as a decimal. So we're going to have 72% for our first probability. And then the second probability, when I select the second person, is technically going to be a little bit smaller than this because we removed one person from the population. However, we don't know the size of the population, so we can't figure exactly how much smaller it is. And also, like in a large population where you have millions or even billions of people, removing one person doesn't change the overall likelihood of selecting another person who doesn't ride the train to work significantly enough that we need to account for it. So that means that we can just do 0.72 for our second probability and for our third. And again, technically it's probably 0.7199999999 or something like that. But it's close enough that we can just account for it in this way. So when I calculate that out, that gives me 0.3732 as my probability that none of the people I select ride the train to work. So that would be question 10. And then on question 11, it says if you draw 3 marbles with replacement from a bag that contains 8 red marbles, 7 yellow marbles, 6 green marbles, and 3 blue marbles, what is the probability that all the marbles you draw are red? So we're trying to find the probability of selecting all red, and notice that specifically with replacement. So in this situation, I have 3 marbles that I'm selecting, so I'm going to have 3 events. And the probability that the first marble is red is 8 out of the total number of marbles. So 8 plus 7 plus 6 plus 3 ends up giving me a total of 24 marbles. Now, if I take out a red marble and I replace it back into the bag before I draw the next marble, the probability that the next marble is red is also 8 out of 24. And same thing with the next one, it's still 8 out of 24 because I'm replacing the marbles back into the bag. And so in this case, when I multiply those fractions together, what does that give me? So 8 over 24, and then we'll multiply that by itself 3 times, and that gives us 0.037037, so I'll just round that up to 0.04. And that would be the percentage or the likelihood that all of the marbles you draw are red. Then on question 12, it's the same problem, except in this case, we're not replacing the marbles. And this time we're drawing 4 marbles and trying to find the probability that all the marbles you draw are blue. So the probability that all are blue, in this case, will be calculated as 4 probabilities multiplied together because we're drawing 4 marbles. So that's where these 4 probabilities are coming from. And then the probability that the first marble is blue is going to be 3 out of 24 marbles because we already found the total is 24. And in this case, since we're not replacing marbles, that means that the next probability of selecting a blue marble is going to be 2 out of 23 because we're not replacing the marbles back into the bag. And then the probability of the next marble being blue is going to be 1 out of 22. And the probability of the last marble being blue will be 0 out of 21 because we don't have any more marbles to select. And that ends up making the entire probability equal 0 because if you do 3 times 2 times 1 times 0, you get 0 over some big number, but 0 divided by that big number will still just equal 0. And so the probability of selecting 4 marbles who are all blue is just 0 because we don't have enough blue marbles to select 4 blue marbles without replacement. So that's how you would do question 12. Then on question 13, we're rolling a 6-sided die and then drawing a card from a standard deck of 52 cards. And we're looking for the probability of rolling an even number and drawing a heart. So remember the AND formula says that the probability of event A and event B happening is the probability of A times the probability of B, assuming that A happens. So if I want to find the probability of rolling an even number and drawing a heart, the way that I would calculate this is I would first say, okay, well, what's the probability of rolling an even number? Well, out of the 6 options on a dice, 3 of them are evens, so that would be 3 out of 6. And then assuming that I roll an even number, what's the probability of drawing a heart? Well, the dice roll has nothing to do with the card that you draw from the deck. So the probability of drawing a heart, assuming that you rolled an even number, would just be 13 out of 52, because there's 13 hearts in a deck of 52 cards. And when you multiply those together, 3 times 13, and then divide that by 6 times 52. Whoops, miscalculated that. 3 times 13 divided by 6 times 52. That gives me a decimal of 0.125. And so that would be the probability of rolling an even number and drawing a heart. And then on question 14, it says you call into a radio station and win a trip to Disneyland. You have 8 close friends, but you can only take 3 friends with you on the trip. How many ways can you pick the 3 friends who go with you? So notice on this one, you're not asked to find any probability. You're only asked to find the number of ways. So our answer that we get should end up being a whole number, and it will be a relatively big whole number. So in this situation, we're making 3 choices. So there's 3 events. And the number of options for who I choose to go on the trip with me first is any of the 8 friends I have available. But then my second choice for the second person who goes with me is 7, because I'm not going to choose the same friend twice to go on the trip. And then I have 6 options for the last friend. And then I also want to ask, does the order that I select these friends in matter? And since it doesn't matter like whether I choose, person A, then B, then C, or if I rearrange that order and choose B, then C, then A, since the order that I choose them in doesn't matter, I'm going to divide by 3 factorial. So basically this is a combination, and if you want to use the combination button in your calculator to do this, you can. But when you multiply those and divide them out, you end up with 56 ways that you can choose the 3 friends to go on a trip with you. And then on question 15, in this case, we have 10 people who are entering a drawing. 4 names are drawn out of a hat, and those 4 people get a free trip to Hawaii. And the question is what is the probability that Bob, Ellie, George, and Hallie are the names selected? Okay, so in this situation, we need to calculate the probability that we select these 4 specific people. So the way I would think about this is I would say, okay, well, the bottom part of my probability is going to be the number of possible ways I could choose these 4 people. And then the top number is going to be the number of specific ways that I can choose Bob, Ellie, George, and Hallie. So for the bottom part of my probability, I have 10 options for who I could choose to go on the trip first, and then 9 for the second person, 8 for the third, and 7 options for the 4th person who goes on this trip. And the order that I choose these people in doesn't matter, because it's not like the first person gets a first class seat and the second person, gets to go paragliding, or, there's no like specification for choosing them in a specific order. So that means I'm going to divide by 4 factorial. So basically, it's like a combination where you're doing 10, choosing 4 people. And that's the number of ways that you could just choose 4 people. Then if I specifically want to find the probability that I choose Bob, Ellie, George, and Hallie, I could choose any one of them to be the first person, any of the 3 remaining people to be the second, and then 2 and 1. And again, the order doesn't matter, so you would divide by 4 factorial. And when you multiply all of those out, the top number ends up being 1, and then the bottom number ends up being 210. And so when you do 1 divided by 210, that gives you a decimal of 0.004761, which is can be rounded up to 2. So that's the probability that you specifically select Bob, Ellie, George, and Hallie. And that's how you would do question 15. Then on question 16, It says you're creating a 5-digit PIN that will consist of 5 numbers from 0 to 9. If you're not allowed to have any repeated numbers in your PIN, how many PINs are possible? So again, we're not looking for a probability. We're looking for how many of these PINs are possible. So our answer should be a whole number. So in this situation, we have 5 events because we're choosing a 5-digit PIN. And the number of options for each digit in the PIN come from the available digits. So the first digit can be any of the 10 digits, but we're not allowed to have any repeated numbers. So that means that the next digit has 9 options, then 8, then 7, then 6 options. And in this case, the order does matter because if you rearrange the order of the digits in the PIN, you're going to get a different PIN or code. And so this is an example of a permutation. And when I multiply all of those numbers together, I end up with 30,240 possible PIN numbers. And so that would be my answer for question 16. And then on question 17, we're ordering a smoothie. And in the smoothie, we can choose 3 fruits, 1 protein powder, and 2 fats from the following options. And we're asked, how many ways could you order the smoothie? So in this situation, we kind of have 3 sets of choices that we're making. So we're choosing 3 fruits, 1 protein powder, and 2 fats. So the way I would calculate this is I'd say, okay, well, I have 3 choices for my fruits. And then I have 1 choice for my protein powder and 2 choices for my fats. And then I want to look at how many options do I have. So if I want to choose my 3 fruits from 1, 2, 3, 4, 5, 6, 7, 8 options, I'm going to have 8 options for my first fruit, but I'm not going to choose the same fruit twice to put in my smoothie. So I'd have 7 options for my second fruit and 6 options for my last fruit. And it doesn't matter what order I choose these in because they're all going to get blended up together. And so that means I divide by 3 factorial. Then when I choose my protein powders, I have 3 options here. So I'm going to have 3 options for my 1 protein powder. And technically you could divide by 1 factorial because the order you choose your protein powder in doesn't matter. But dividing by 1 doesn't really change very much. And then when I choose my 2 fats, I have 1, 2, 3, 4 options to choose from. So I would have 4 options for my first fat, and then 3 options for my second fat. And again, the order that I choose these in doesn't matter. So I'm going to divide by 2 factorial. So basically we have 3 combinations. And when I do 8 combination 3 in my calculator, I get 56. When I do 3 combination 1 in my calculator, I get 3. And 4 combination 2 gives me 6. So when I take all of those results and multiply them together, 56 times 3 times 6 ends up giving me 1,008 possible ways that I could make this smoothie. And that's how you would do question 17. And then our last question on the practice test, I'm going to add a new page just so I have room to scroll up. This one says, the following table shows claim amounts and their probabilities for an insurance company that offers homeowners insurance policies. Calculate the expected claim amount. That is, on average, how much will the insurance company have to pay in claims per policyholder? So this one's really nice because if we're trying to find the expected claim amount, that's just the expected value, and they've already calculated all the probabilities for us, as well as listed out all of the possible dollar amounts that you can get for that. So when you multiply these together, because that's how you do expected value, 0 times a probability of 0.47 is just going to be $0. 50,000 times 0.28 ends up giving you 14,000. And then 100,000 times 0.15 ends up giving you 15,000. And 150,000 times 10% or 0.10 ends up giving you 15,000 as well. And when you add all of those up, 14,000 plus 15,000 plus 15,000 gives you 44,000. And that would be the amount of money that you would be expected to, or that the insurance company would be expected to pay on average per policyholder. So as an insurance company, they just need to make sure that they charge their customers more than that, so that they don't end up paying out more than they collect from their customers. So that's how you would do question 18. If you have any questions on any of these parts of the practice test, please let me know, and good luck on your test.